Hey guys, in this video I'll discuss the motor mounts for the G0704 belt drive conversion. This is for a 2.8 horsepower DC treadmill motor, and there is a link in the description where you can see drawings of these three parts, but please do not follow them exactly. You need to take your own measurements. Your motor shaft may be a different length, which means your standoffs will be a different height, and also the bolt hole locations may be completely different for where the standoffs bolt to the mill head. I've also made some other changes in the drawings, and so they're not going to look exactly as you're seeing them here, and I'll explain that a little bit more as we go. Because my mill motor died, I needed some motor. So I actually just made my original motor mount out of wood, and this lasted a long time, and it's why this video is taking so long to be rolled out, because I actually used this wood motor mount for months. I think maybe on my table saw, I have a cheap table saw, I've cut these standoffs and then just stacked up wood shims until I got it to the right height. And then I made a top plate for the motor to set in and on, and screwed the whole thing together. The standoffs are drilled and counterbored to be bolted to the head, but then the shims and the top plate are just screwed to that. So the biggest problem was I couldn't tension the belt very much, and that actually caused its own set of problems. For some reason, I keep losing footage on my camcorder. I'm wondering if it's pretty old. It's starting to get old, and I'm wondering if the internal memory is becoming corrupt, because I keep losing clips. I don't know how this happens. It's gotten really bad the last 2 or 3 months. Anyway, I don't have the footage of me making all of the aluminum version of the top plate, so I'll show you the wood one. Basically, bore it out on the lathe. You could also helical interpolate a hole on the mill, which is how I did the aluminum one. And then you need to leave this flange at the bottom, and that is for the motor to sit on. There does need to be a couple of little areas clearanced in that flange for the motor's carriage bolts, the bolts that pass through the motor. And you'll see those a little bit better in the aluminum version here in just a minute. This footage is, the only reason I'm showing you this is because you may notice, you're going to notice my standoffs have this scalloped clearance area, and that was intended to be clearance for the large belt pulley that attaches to the motor. After I got the whole thing assembled, I realized I did not need to clearance this, so it's not in the drawing, and you won't need to perform this step. It's just it kind of makes it look cool, I think, but it's extra time that you don't need to spend. So forget about machining this shape into each of the standoffs. The one thing you will need to do is drill 4 holes in each standoff. 2 of the holes are going to be for bolting each standoff to the mill head, and then 2 more bolt holes for machining for bolting the top plate to the standoffs. I went with 1032 bolts for the top plate, but in the drawing I'm going to specify something larger, probably 1/4 20. There's a bunch of reasons for that, but just know that it will be easier to machine if you go with the largest possible bolt. Also, the slot in the top plate for tensioning the belt will be easier to machine, because I had to use a small 1/8" end mill, which you'll see here in a minute, and I machined it from both sides. If I could have used a larger end mill, I could have machined it all in one setup, and also the bolt head would have much more area to grip onto the plate within the slot. I hope any of that makes sense. Another thing is the way that I machined these 2 pockets you're seeing are for the bolts that actually bolt it to the mill head, and I changed that design a little bit in the final drawing as well. Okay, so I started to make this the same way I made the wood one, and I was planning on boring the whole thing out on the lathe, and then I realized that would just be a huge waste of time. So I drilled 1 hole, but then I ended up going over to the mill and doing a helical interpolation. Somehow I lost all of that footage, well, almost all of it. So here it is after, basically I cut a circle out, then I removed a puck-sized piece of aluminum, and then here you can see I'm doing the cleanup pass, machining around the larger diameter, and then I'll leave about 1/4 inch at the bottom for that flange. You can also kind of tell if you look at the top and bottom of the y-axis is where right there you can see it is clearance for the carriage bolt heads, and you'll need that as well. So again, just some more passes, cleaning everything up. And no, I'm not machining right on the table. I've got a piece of, I think, 1/32 aluminum sheet underneath the plate, and so that way I don't gouge my end mill into the table. Anyway, just more of the same, I guess, going in circles. There you can see, I guess you can't because there's too much chips and coolant in the way, but you can see the clearance. Right there, you can see it for the carriage bolts again. Now, what I did was leave about 20 thousandths, and then I came over to the lathe and took that last 20 out. This way I could get a perfect circle, and I could really sneak up on getting that motor to fit in there nicely. It's not a tight fit at all, but there's no slop. I ended up with a really nice fit, and it worked out really good, really well. Okay, so back over to the mill. Now, here is where I'm cutting the slots for the bolt head. So the bolt head will fit in this slot, and then I have to flip the plate over and machine it again with a smaller end mill to get the slot for the bolt, the threaded part of the bolt itself. So here you can see the plate is upside down. You'll also notice there are long slots running the entire length of the plate. This is on the bottom side. The idea for those was to allow the plate to actually sit over the standoffs a little bit, which would act as guides. That's not in the drawing because it's not necessary. The slots themselves will keep the plate more or less aligned. If you need to tap it into perfect alignment after you put tension on it because you care that much, then so be it. If you want to machine runner slots for the standoffs, go ahead, but they're not going to be in my drawing. And then the last step on the plate, well, I guess I shouldn't say that, was to machine the outside. And this actually took 4 setups because I'm so limited in the y-axis travel. I had to machine one side and then flip it around and machine the other side, and it took a while. But I did actually grow a lot of confidence in multiple setups. In the past, I've always dreaded having to set a part up multiple times because I thought I would mess up an offset or something and ruin the part. But no, it actually worked really well. So you can see I left this boss, and the reason for that is I drill a cross hole, and then once I get the cross hole drilled, and you're going to need a long drill bit for that, I machine a slot, and then that allows me to put a bolt through that cross hole, and then I can apply tension onto the whole thing. Now you may say to yourself, well, with the bolts in the slots holding this thing to the standoff, how tight can you really tension this cross bolt? Come to find out, pretty tight. It actually works really, really well. So here you can see how the whole tensioning system works. There was one problem where my belt ended up being too long, and somehow I mismeasured for that. So what I'm doing here is just scribing the slots onto the standoffs, and then I took the standoffs, re-drilled and tapped those 4 bolt holes, 1032, and that was it. So here are a couple of pictures of the finished mount, and it was a long, stretched out, terrible project that I'm happy it's over. I kind of lost interest, and I just wanted it to be done. So the video, I apologize, it's disjointed and really not very interesting at all. Anyway, don't forget to check out that link if you want to see the drawings. Hit like while you're down there, and subscribe to my channel if you're new. And I'm going to throw another video up here in just a couple of days. Thanks for watching, guys.